Hey there, just wanted to give another quick update because I realized I didn't talk about one of the pretty significant thing that I set up in the last couple of weeks that I haven't really had a chance to go over in detail, and I won't be going over it in too much detail right now, but just wanted to show kind of what I was, you know, trying to implement before, but now have implemented. Okay, so the thing that I've implemented that is unique to that doesn't that Lyra really doesn't have is a solid projectile system. The system in the SneakyKitty game shooter framework is, a good start at implementing a projectile system. I know that the dev has intentions to revamp it, but it's a really good start. It, uses, can to grab wind velocity, gravity is involved. Um, the projectiles themselves are kind of, controlled by these data assets. So basically, you can set parameters in the data asset per projectile. So that's basically like bullet stats, kind of in the framework. And so yeah, so it's a good start. And as the dev begins to re-implement newer logic or kind of push people towards a more robust plugin, terminal ballistics. This way in Lyra of implementing it should kind of hold in a sense. It should be valid. But anyway, so just want to kind of go over what it took to get to this place. So previously I had weapon fire, and weapon fire would basically call the fire function on the projectile on the weapon. The weapon was based on the SneakyKitty game's base class, the weapon SneakyKitty game's firearm. So um, in that firearm framework, basically there's in this firearm blueprint, you'll see that there's a function in here called fire, which I think is here. Yep, fire, right? So this function was being called in the old way. So basically calling all this function so that we could, spawn on server and get all the kind of get all the replication and then basically the fire effects, and then firing the projectiles called here, and then fire projectile, which is another subfunction. Would basically call the SneakyKitty Games world projectile world subsystem. This is the core of the projectile logic in this subsystem. Here's the projectile data, actors to ignore, getting the muzzle transform, right? So getting the muzzle transform and then spawning a projectile based on the muzzle transform, and then this is doing all the C++ backend logic for calculating the projectile. So that's clear that that's where we needed to be with that, but we want to implement that in a Lyra gameplay ability way. So, so that's what I was doing in the old way. It's just basically calling that function on the firearm. And there's some drawbacks to that. Some of the drawbacks involved, first of all, that the weapon itself had to be a child class of this BP SKG firearm, and not the Lyra firearm, which is the B weapon firearm. So the B weapon firearm is located in this top directory under weapons. It's the base firearm class that all the weapons in Lyra are based on. So any weapons in Shooter Core all trace back to this B weapon, um, unless they're projectile weapons. Actually, I think even projectile weapons do. But projectiles in Lyra are implemented as kind of your standard, spawn a capsule overlap kind of detection logic, and then apply a gameplay effect to that. But that's not what we want to do in this relative to, that's a very heavy way, a computationally heavy way to spawn a projectile. It's great for smaller things like grenades or one-offs like that, but when you start doing rapid fire and things like that, you want something more efficient. So the SneakyKitty game shooter framework has that basic projectile logic built into it. But what the SneakyKitty game shooter framework doesn't have relative to this projectile, and I can kind of review that with you a little bit in um, in Lyra here real quick, is just to go over this, is it doesn't, if we look at weapons here, basically if we go into, let's say, the rifle, and we go to gameplay ability weapon fire rifle auto, so this is the basic gameplay ability that that is implemented by, well, this is the last chain of the gameplay ability that is implemented by the rifle, okay, to basically fire the rifle. but it's all coming from gameplay weapon fire. So if we go here and look at this, which is again at the top level, um, you can see that all the logic for firing the weapon is here, and it's this node here that's calling the C++ function range weapon target data ready. And target data here, don't think of this as target as in like you're shooting a target and it's the target that you're shooting. Think of this as the target is the gameplay ability system attached to the character that you're either the source or the source or the target of the effect or the gameplay ability. So this is the target of what the gameplay ability or gameplay effect is going to work on. And so the way that Lyra weapons work is they use a line trace to shoot out into the world and touch things, right? Impact things. And if that thing has a gameplay ability system component on it, then this thing can implement things and register events and change data in the gameplay ability system. So it can change attributes and things like that, attribute data, based on the target ability. And you can see that this has a gameplay ability target handle structure, data handle structure. So that's what's being passed from this, right? So the line trace, the hit scan weapon, is grabbing data from this so that it can then do stuff with it, right? So this target data structure has within it concepts like a typical hit structure, hit result, has target data actor and all the stuff that comes along with that, which you can break out with these functions, get hit result from target data, and then make, so you can get hit result from target data. From there, you can start beginning to make gameplay cues from that target data, and then you can do other things, including, and this is where we're going with this, applying gameplay effects such as damage, right? So this gameplay effect damage is being applied to the target of the whatever the target is of the gameplay ability component, right? So that is what we're talking about here, and I say that because there was an intermediate step in this where you have to understand that often the target that is being hit by the or being touched or being acted upon is being told often not how do I explain this, that one actor is not damaging another actor directly, rather an actor is interacting with another actor and then telling that actor to damage themselves, to apply a gameplay effect to themselves. So that can be a confusing concept here, because you're thinking, I shot a bullet, the bullet hits another actor, and then the actor is damaged by my bullet. Yes, there is a chain of ownership from the actor to the affected actor. However, in the gameplay ability system, it's often applying gameplay effect to target is instigating the actor and themselves to apply the gameplay ability to themselves, to the source. Okay, so just want to be clear, because that's where I had some problems with this initially in trying to understand how to do this, which is why the only way I could get around it initially was to apply the gameplay effect to self, right? And this is a kind of long form way of doing what I'll show you I did in C++. But basically, you're getting the hit result, okay, from the impact, because SneakyKitty Games World Subsystem has an on impact delegate that can then pass a hit result, which you can break. You can also I had to do this here. I did this just because out of expediency, but recombine it so that I can make gameplay cue parameters from hit results, so we can get like the splash or the hit effects from the different gameplay characters and things like that. And then and then from that hit actor, you can see if there's a get ability system component, and then make an effect context. Again, this is very gameplay ability specific. This effect context tells the gameplay ability kind of like what kind of what are the parameters that it's going to use to apply the gameplay effect, and then you can apply the gameplay effect to yourself, right? So whoever's hit by this projectile is going to apply damage to themselves. So that's what I meant by that. So this is the only way I could get around making sure that clients and server were applying damage to themselves, which then led me to understand that this is what we need to do in the projectile. So the new way that I'm doing it now, I don't need to do all of this. Rather, I can do that in, I did that in C++, and I'll show you the class in a second here. But I basically now have my own child class of the SneakyKitty Games projectile subsystem, which calls this delegate on impact and on metal projectile. So this impact basically does something very similar, except now it applies effect to target. But don't be confused. I'll show you this in C++. This apply gameplay effect to target, which is very similar to what's happening here, apply gameplay effect to target, is kind of hiding the fact that in the C++ code, really what's happening is that this is really happening. Apply gameplay effect to self is still there doing this work. It's just named target because it's the way we would think about this more clearly, like applying a gameplay effect to a target, which again has kind of an owning chain of cause effect that's more clearly in that language than it is in applying it to yourself. It's a little bit counterintuitive to think about that way. So anyway, so that's kind of what's happening here. And then so yeah, so if we go back into C++, I can kind of show you what that means. So this is my child class of the SneakyKitty Games Shooter Frameworks projectile class. So if I just go there and let's just go find it here, projectile. So we're overriding the fire projectile. Let me say once again that I did actually have to change this base class, again for expediency, in a couple ways in order to get this to work correctly. So this delegate that gets called, right, this on projectile impact, needs some more parameters that we can pass back to the needs to pass, when it gets called on impact. A couple of those are related to the gameplay effect, right? So T subclass of U gameplay effect is a parameter that we're now embedding into this delegate, and also the projectile owner is what we're also passing back. So both of these two things allow us to kind of get a little bit more information on what we're hitting and then do this in a more kind of robust way. So in this, I'm calling fire projectile, but now I have the concept here of a gameplay effect and an owner, and then I wrote a custom function here for the which is related to the gameplay ability system that allows the gameplay effect to target, right? Okay, so when we're on hit and we call the on hit function delegate, we're basically when we call the when we call that delegate, basically we're able to apply the gameplay effect to the target, and we're able to do that so that, and the reason I added the projectile owner is so that I could ignore the person that's shooting, right? So if you're shooting and you don't want to be able to shoot yourself in the foot, and so yeah, so the projectile owner allows us to filter out whoever owns this, and will allow us to do that for other kinds of projectiles that we want to apply various damage effects to people who own things. So for instance, since you know who the projectile owner is, you can create a subclass of this that allows you to throw a grenade, have the explosion happen, and your teammates and or yourself maybe aren't damaged quite as much as the enemies, right? It's kind of a common gameplay design kind of thing. So yeah, so anyway, so there's that. So this function basically, remember, in the end, we're actually applying the gameplay effect to self here. You can see that here, right? So in the end, we're getting the effect spec handle, and then we're applying it to ourself. It's just that we're kind of hiding that behind the apply gameplay effect to target, right? So that's what's happening here, and that's typical of the gameplay ability system, and I just want to point that out. Okay, yep, so that's the other thing that was implemented in the in this gameplay ability. And let me just cover what it means now that we're inheriting from B weapon instead of inheriting from um, the SKG firearm class. So remember, we can take stuff from this class and learn from what's here and re-implement it into our own game. And that's really what this example project is. If you go to the Discord for SneakyKitty Games, he's very clear. Like, the example project is only a fraction of what this incredible framework actually has in it, and it's kind of just an example of how you would implement things. So that's how I'm using this now, is just as an example of how we might implement some of these functions that are all basically in C++ within the framework to use these in order to get what we want, but now do it in a Lyra way for the gameplay ability system. So the other thing, so what I was saying is that, now instead of having to inherit from firearm class within the SneakyKitty game shooter framework, we can actually inherit from the B weapon class in Lyra, and then add things to this functionality. Child class this when we start adding and changing things, and get all of this functionality in there. And so why is that important? Well, it's important for one major respect, which is that the B weapon is calling a lot of things related to gameplay cues, and gameplay cues are the kinds of things that will like do weapon impacts or sounds and things like that. So you can see that here we're getting B weapon impact respawning a blueprint actor on impact, and respawning another blueprint actor on fire. And if we go to that blueprint actor, and we're basically attaching that to the actor component, and this is destroyed when the character is destroyed. So this B weapon fire, once you spawn it, is basically going to hang out with you the entire time you're playing the game, and then operate the way that it operates on your character for the full lifespan of your character. So that's how Lyra implements this B weapon fire. B weapon fire is then we can now take this class, and we have things like grabbing things from B weapon fire, like the weapon that we're using, and we can get things from the weapon. So we can get the skeletal mesh of the weapon and the transform of the muzzle, and we can start using those things to basically spawn shell eject like they have here, or firing effects basically here, muzzle flash, tracers and things like that can all come from here. Lyra weapons are initially rotated 90 degrees. So, you can, this is how they implemented this make rotator to, when you spawn the weapon in, kind of resolve that weird kind of rotation of the weapon, but, and the muzzle. But here we can just take the muzzle rotation, explicitly, because we have a muzzle, how do you say, socket, on our weapon that we want to use for spawning projectiles and things like that. So now that we've inherited from B weapon instead of the SKG firearm class, we're able to do a bunch of this gameplay cue stuff. This gameplay cue stuff will then kind of prompt you in a way, because it will require this of you, for the audio component of this. So when you shoot a weapon and you spawn an audio thing, will then prompt you to, within your gameplay ability, you'll have to, and this is getting kind of deep here, but I just want to show you kind of all the things that involve, that are involved in this. So if we go to system and audio, you have all these weapon audio functions that you need to bring over from shooter core content, and I'll do a video on this and how to do this, but you need to bring all this stuff over here, because remember, our plugin doesn't know anything about shooter core, and we don't want it to, and it's only able to grab things from this top directory. And again, this top directory can't grab things from our plugin. It's a one-way street. We grab from here, everybody can grab from here, and we can only grab from inside our own plugin and here, and not from shooter core. So getting things over here that you need from here is the way to go. And so you will need to grab these things, which means that in a sense, if we go back to our primary thing here, so in experiences and the experience ability set, well, this is where we implemented respawn. Let's go back here, action set, quick art component, shooter game, add widgets. Nope, this is where we're adding all the stuff. Let's see, where did I put that? So, oh, so here, okay. So we basically need to add components, and one of the components that we need to add for audio is we need to add this music manager. Okay, so I've created my own music manager, which is just a duplicate of the normal music manager and brought into my plugin, because in this music manager, if we open it, there's some things that I don't really want to have happening here. And so if we go back to BP component base and go in here, for instance, the music system, I don't want the music system to be playing, so I can just turn the volume multiplier down to 0, right? So this music manager actually handles all of the audio for the game. You want this music system manager. It's a little bit confusing that they call it a music manager, but you do want this audio manager in your game, at least initially, probably, because it does some really wonderful things relative to calculating um, the weapon effects and sound effects, relative to distance to other actors, and allows for at least a basic 3D audio component, which is not something that takes 2 minutes to build. It's quite a bit of work and effort that goes into making it. So at least as a starting point, that's how I feel. Like if they have it in Lyra, let's try to use it and leverage it. And the music manager is important to that. So that's why we're going through all the effort of getting B weapon to be the base class for the weapon that we're spawning, so that we can have this chain of things that happens all the way through to even the audio, to get that all implemented in. Um, and again, like that starts with the just the desire to make a projectile kind of leads to all that other stuff cascading and having to be developed. I'll make a tutorial on this at some point. I think the next tutorial that I will make will be on how to set up the camera stuff, ADS and all that, and just get firing kind of implemented, which will then lead to a tutorial series on how to get this done, which will lead then to how to do all the rest of this stuff. And yeah, so then the other component of this basically is that that we are now spawning the actor into the hand of the character, no longer in the way that the old way that SKG does it, the SneakyKitty Game Shooter Framework does, which is the simple way, understandably, since it's just an example, of just spawning the actor into the character's hand and then calling this pickup firearm function, which has the logic in it to ultimately lead to calling set held actor, right? So this is the C++ class that allows the SneakyKitty Game Shooter Framework to understand what weapon you're holding and what all of its components are that allow for the procedural stuff and all of the attachments. So this is the critical C++ class that we're trying to get to. Well, in order to do that in the Lyra way, what we have to do is we have to set up the inventory, because Lyra's weapons are all inventory fragments, item fragments, that basically are managed by the equipment manager, and all things spawned into Lyra for the character are managed by the quick bar slot. This quick bar slot is created and then instantiated so that we have the inventory manager and we have the quick bar slot, and that quick bar slot then kind of allows us to have the quick bar slot. Remember, the quick bar slot is not necessarily just the little HUD icon that you see down here. It's actually a data driven basket, let's call it, that has a certain number of objects in it, and those objects can be cycled through, and they have all the stuff that grabs that stuff. So there are a couple of things you need to do to the quick bar slot to get it to work, and I can show those in a future video. But needless to say, what we need to do to the quick bar slot is basically add a function that allows us to grab the first item in the quick bar slot, so that we can so basically, yes, so this is a function that I had to write in order to get the first item 0, the one that's equipped within this array. so that when the array is changed, it gets item 0, the first item in the array, the one that you have equipped, and it basically equips that weapon. And what that allows us to do is send this first item into pickup firearm to call the Sneaky Kitty Games held actor function. So this stuff kind of has to be implemented in order to get the weapon to be spawned into the character's hand, um, in the Lyra kind of framework way. So yeah, so that's kind of an overview of the way that the weapons are working in this as I begin to integrate weapons with that stuff. So with the Sneaky Kitty Game shooter framework and tie these two frameworks together. And yeah, so let me do a tutorial here at some point about how to get this up to speed, but I just want to give another quick update on the other thing that I was working on over the last couple of weeks, was just getting these projectiles to be able to spawn and work with the SKG world subsystem, projectile world subsystem, and apply gameplay effects, when they hit their targets, so we can damage players and do that kind of stuff. Okay, thanks.